The RSH or Riser Speed Head system offers many improvements in efficiency, well control, and safety, and is a perfect match for drilling operations in shale plays, as is listed below. The start of the installation process for the RSH system begins with the installation of the landing ring, and then the riser from which the system is named. The riser includes intermediate connections to facilitate sectioning of the riser. On this slide, the set screws can be seen running into the conductor pipe. This connection is set by friction alone to contain hydrostatic pressure. For cases where it is necessary to contain pressure beyond hydrostatic pressure, such as when air drilling, other riser options are available, which provide a mechanical lock with the landing ring to contain the elevated pressure. Functionally, the riser directs the flow of drilling fluids flowing up the wellbore of the conductor pipe, while drilling for the surface casing string to be suspended by the RSH housing. After drilling inside the conductor pipe for the surface casing string, it is time to run the surface casing string into the well. The surface casing string is threaded into the RSH housing, and the housing running tool permits torquing of the casing string into the housing as is shown in this video. The same pins that are used to rotate the tool onto the housing via the handle ends are used to also transfer the rotational torque to the casing string to make up the surface casing connection per spec between the RSH housing and the casing string. This slide illustrates the running of the RSH head into the riser using the made-up tool. The housing lands on the aforementioned landing ring. After the RSH housing is landed, drilling riser may be removed as follows. With minimal vertical space needed, the riser's upper section is detached and eliminated at the intermediate connection. With the upper section of the riser removed, there is plenty of space to lift and remove the lower section of the riser as is shown surrounding the housing below. Note that the intermediate connection in the riser utilizes a mechanical lock with screws running into a groove. Thus, this connection is built to suit elevated pressures during air drilling operation. This slide simply illustrates the vertical lift of the remaining section of the riser for riser removal. Outlet valves are installed with riser out of the way as shown on the following slide. After eliminating the riser, which was used to drill inside the conductor pipe in preparation for running the surface casing string, it is now time to prepare to drill inside the RSH housing for the intermediate casing string. The first step in preparation is to thread on the drilling adapter's ring, which is used to mount the RSH Quick Connect drilling adapter to the RSH housing. The RSH drilling adapter, which is pre-installed to the base of the BOP, is fastened to the RSH housing. The adapter's pin-actuated dogs contact the hub of the drilling adapter's ring that was pre-installed on the housing and are torqued according to specification to make up the connection for rated pressures and bending capacities. After the BOP and drilling adapter are installed to the RSH housing, the connection between the RSH housing and the drilling adapter is tested. To facilitate this, a test plug is lowered into the bowl of the RSH housing and will form a barrier to contain fluids above used to test the integrity of the connection. After successfully testing the connection, a wear bushing is run into the RSH housing to protect the inner sealing surfaces of the housing while drilling inside the surface casing string in preparation for the intermediate casing string. The wear bushing is run with the same combination tool previously used as a test plug, but in the inverted orientation for running the wear bushing. Drilling is performed inside the surface casing string. After drilling is complete, the combination tool used to run the wear bushing is removed by rotating counterclockwise. While rotating, the tool's spring-loaded pins used to run the wear bushing retract from the wear bushing's windows to permit the removal of the tool from the well. This slide shows the spring-loaded pin in the window. After drilling inside the surface casing string for the intermediate casing string, it is time to run the intermediate casing string into the well. The intermediate casing string is threaded onto the RSH mandrel hanger, and the hanger running tool permits torquing of the casing string into the hanger as is shown in this video. In this particular step, the tool body is made up to the hanger by rotating in a counterclockwise direction for the left-handed threads. A torque collar is placed around the connection between hanger and tool in order to transfer torque to the casing hanger. This permits torquing of the intermediate casing string to the hanger's pup joint thread into the hanger using the rig's CRT, casing running tool. The connection between the intermediate casing string and the pup joint is torqued to spec by rotating the tool clockwise. After the connection between the casing string and pup joint is torqued according to specifications, the torque collar is removed manually at the rig floor. The hanger is then run into the well and is landed on the inner shoulder of the RSH housing. The intermediate casing string is then cemented in place. The intermediate casing hanger contains multiple outer flutes to permit upward flow of drilling fluids back to surface during the cementing operation. After the cementing operation is complete, the pack-off is ready to be installed to seal the annular space around the intermediate casing hanger. The pack-off running tool is made up to the pack-off with a few counterclockwise turns on the left-handed Acme thread. The pack-off is lowered into the well until it lands on the intermediate casing hanger. The pack-off's lock ring will not yet be energized, as can be seen below. Note the spring-loaded pins in the detail view. These pins, once sprung out into the mating grooves on the hanger body, prevent rotation of the pack-off when locking the lock ring and when removing the pack-off tool in the subsequent steps. After the pack-off is landed, the pack-off running tool is rotated further in a counterclockwise direction. This pushes the energizing ring down, causing the lock ring to expand, thus locking the pack-off in place. Note shown below. After the pack-off is locked in place, the pack-off running tool is removed by rotating in a clockwise direction. The spring-loaded pins prevent rotation of the pack-off during this operation. Shown below, the previously used combination tool test plug is run again, but this time set on top of the pack-off in order to retest the BOP connection if required. After successfully testing the connection again, if required, a wear bushing is run into the RSH housing and landed on top of the pack-off to protect the inner sealing surfaces of the housing while drilling inside the intermediate casing string in preparation for the production casing string. The wear bushing is run with the same combination tool previously used as a test plug, but in the inverted orientation for running the wear bushing. Drilling inside the intermediate casing string is performed. Similar to the previous stage, after drilling, the combination tool used to run the wear bushing is removed by rotating counterclockwise. While rotating, the tool's spring-loaded pins used to run the wear bushing retract from the wear bushing's windows to permit the removal of the tool from the well. After drilling inside the production casing string for the production casing string, it is time to run the production casing string into the well. The production casing string is threaded onto the RSH mandrel hanger, and the hanger running tool permits torquing of the casing string into the hanger as is shown in this video. In this particular step, the tool body is made up to the hanger by rotating in a clockwise direction for the right-handed threads. In this particular step, after the tool bottoms out on the hanger body, the tool's spring-loaded keeper pins are manually pulled to permit the spring-loaded torque pins to spring out of the tool's base. The torque pins then catch matching grooves on the hanger shoulder. In this particular step, the casing string is being rotated clockwise while running it into the well. This rotation feature is helpful to assist in guiding production casing through the bend into the lateral section of the well. Rotation of the casing may also be utilized to improve the cementing operation by aiding in the elimination of gases from the cement. This slide illustrates the mandrel hanger being lowered into the well. Rotation of the casing is possible throughout this operation. The hanger is cemented in place. This slide illustrates the mandrel casing hangers tool being removed from the hanger. This is done by rotating the tool counterclockwise. The tapers on the torque pins cause the pins to retract to permit tool removal. After the cementing operation is complete and the hanger's tool is removed, the pack-off is ready to be installed to seal the annular space around the production casing hanger. The pack-off running tool is made up to the pack-off with a few counterclockwise turns on the left-handed Acme thread. The pack-off is lowered into the well until it lands on the production casing hanger. The pack-off's lock ring will not yet be energized, as can be seen below. Note the spring-loaded pins in the detail view. These pins, once sprung out into the flutes on the hanger body, prevent rotation of the pack-off when locking the lock ring and when removing the pack-off tool in the subsequent steps. Similar to the previous lower pack-off, after the upper pack-off is landed, its running tool is rotated further in a counterclockwise direction. This pushes the energizing ring down, causing the lock ring to expand, thus locking the pack-off in place. In order to safely contain wellbore pressures, a back pressure valve is run into the mating threads within the pack-off using a lubricator or back pressure valve running tool. With the well safely shut in, the drilling adapter and BOP are removed. The reverse steps of the installation procedure are performed to remove the drilling adapter. With the BOP and drilling adapter removed, the drilling adapter's ring is unthreaded from the RSH housing by rotating the counterclockwise direction. The API flange is threaded onto the RSH housing in preparation of installing the tubing head section above the RSH housing. With the API flange in place, the tubing head is installed. The API connection is made up according to specification. The tubing head's lower ring gasket and casing seals are immediately tested for pressure integrity. After testing the tubing head seals, the lubricator or back pressure valve tool is once again used to remove the back pressure valve. This completes the installation of the RSH equipment. With the conventional tubing head installed, the well is ready to receive the mandrel tubing hanger and Christmas tree, for which a multitude of options are offered by GE for various material classes, temperature ratings, sizes, pressures, and feature options.